So we talked about range of motion and flexibility. Yes, this is HBS. Range of motion is different for different people because essentially it depends on, oh, come here. What is this? Hold on, I'm fighting with the laptop. Okay. Range of motion different for everybody because it depends on how your joints were formed, if you will, in adolescence. So like right about now. Our gymnasts, the ones that go to the Olympics, you may have noticed how young they are. They're really young. They started really young too. And so that gives them the flexibility and the muscle control that they need. For us, if you're thinking about physical therapy, that's kind of like the little range of motion activity. A lot of times they're going to recommend stretching exercises and movement of joints. You may have heard like an arthritis commercial where they say get up and get moving because that helps things out. Well, as you're moving those joints, it helps to lubricate those joints. It helps to stretch things out. So movement is always a good fix, non-medicinal fix. Not to mention the fact that it can help release natural endorphins. So that's the natural pain-relieving, natural like calming, pleasure kind of neurotransmitters that we have. All right, so I had my skeletal system was a tab at the top. I've got one for muscular system. So I did the same thing. My little post-it note, and on my post-it note on the front, it says muscular system, and it kind of dangles so I can see right where that's at. And on the back, I've got the function of the muscular system. So the function of the muscular system, that's the job, its job is to allow movement through contraction and relaxation of muscle fibers. Functions of muscular system to allow movement through contraction and relaxation of muscle fibers. And it just says muscular system on the front. Yes. Oh, wait, no. No. We did investigation number 1. And honestly, I wrote it down, but I don't remember what else. Oh, we went over the 1, 2, 1, 1, 2, 2 stuff. So Severin's already done his. So whenever you're ready, and my suggestion would be go over those 2 assignments, make sure that, if I say where's orbicularis oris, what does it do? That's kind of what I'm going to do from those 2 assignments, and then let me know, and then I'll update your grade. I don't know. We didn't put anything else in there yesterday. It was notes and then investigation number 1. Now, we did put stuff in for investigation number 1, but those are the pictures I sent you. So joints have a lot of different motion. They have a lot of different range of motion depending on the joint. Muscle fibers, they contract and relax. That's essentially what they do. So our different types of motion is all related to what kind of joint's working and the muscles, which muscle is contracting, which muscle is relaxing. Because there's a myriad of layers of muscle that are at work in every motion that we have. All right, so types of muscle. Put that over there on the side. We have voluntary and involuntary muscle. Those are the two types of muscle. Skeletal, cardiac, and smooth. Those terms may sound familiar to you, but we looked at those in terms of types of muscle tissue. So there's two types of muscle. It's kind of like types of bone. We have flat, irregular, short, long. Types of muscle, we have voluntary, involuntary. Skeletal muscle, cardiac muscle, smooth muscle. Those are types of muscle tissue. So voluntary muscle, we have voluntary control for the most part. Involuntary muscle, we don't have conscious control, or we have a very limited conscious control. Cardiac muscle is associated with the heart specifically. Smooth muscle, digestive organs, diaphragm. So the diaphragm is that muscle that allows us to breathe. When it contracts and relaxes, it changes the volume of our chest cavity. Oh, it's not set up. My balloon. I think we looked at this before. When did we look at this before? Didn't we? Well, yeah. I can't remember what it was in reference to, though. Oh, okay. I know it was PBS, but I can't remember why. I just love this model. I think that's so cool. But, so obviously no muscle tissue in the lung itself. The diaphragm is the muscle tissue that allows us to breathe. It's involuntary. However, Severin might say something along the lines of, but Mrs. Johnson, I can hold my breath. Yes, you can, I would say back to Severin. However, you hold your breath long enough and you pass out, your body's going to have you start breathing again. So limited control, but we don't really have conscious control over involuntary muscle. Wasn't that what you're about to ask? Yeah, I figured. Yeah. I mean, like I said, if you're able to, if you're a champion breath holder, eventually you're going to pass out. And then your nervous system is going to take control and have you start breathing again. You realize he's not really like walking through walls, right? Yeah, he does all sorts of stuff. And there are some people that can hold their breath for a ridiculous amount of time. But I think, like, when I say 5 or 6 minutes is basically you've depleted your oxygen stores. We can't store oxygen. So that's why it's only a few minutes before we run out of oxygen, because it's not like glucose that we can store as glycogen. It's not like calcium that we can store in our bones. We don't have anywhere where we can store oxygen for when we need it. So whenever it runs out, where it's on your red blood cells, then that's it. Too bad we're not like those little. So remember when we talked about vital statistics and we looked at CBC? So our complete blood panel there, the complete blood count. There are folks that swim and dive for their profession. They do that kind of on a daily sort of basis. They're going to actually have a higher red blood cell count, a higher erythrocyte count than, say, me, who can't hold their breath past 10 seconds, because why? people that live, you know, in higher elevations have a higher erythrocyte, higher red blood cell count. So if you have more red blood cells, you can store, I mean, essentially more oxygen. You're not really storing it, but you have more attached to red blood cells, so it's going to take it a little while longer. But there is still a limit to that as well. All right. Yes. Well, some programs can take new students in at any time. So that brings up a good point. In years past, when you did your orientation, you set up a remind account at that time. Like they gave you a little code. Does that sound familiar from when you guys did orientation? So maybe that, and that's where the text messages would have gone in the past. So they would have put out a big text message, a blanket text message to everybody about weather. If you have any questions, just text me. I'll know by then. Striated muscle. Okay, so that's my little bullet. I was feeling creative, I guess. So striated muscle is muscle that looks like it has stripes. The striations are created by actin and myosin fibers arranged in sarcomeres. I know that doesn't make sense. Just write it down. When we get to talking about muscle contraction, it'll make more sense. So striated muscle is muscle that looks like it has stripes. The striations are created by the actin and myosin fibers arranged in sarcomeres. Sarcomeres, S-A-R-C-O-M-E-R-E-S. I don't even know. Hang on. Oh, yes, E-S. S-A-R-C-O-M-E-R-E-S. This is nothing. Sarcomeres, that's an R. And no, there's no space. Cardiac muscle and skeletal muscle are striated. So they have those little stripes in them. They have those striations. At least you can't sneak up on anyone. Cardiac muscle and skeletal muscle are striated. Smooth muscle has those myosin and actin fibers, but they're not arranged in those sarcomeres, and so it doesn't have those stripes. It doesn't have the striations in there. So it has the same components. They're not just arranged and put together the same way. Right? Always, always. Now we talked about these components when we looked at bones and joints, but good review. Tendons attach muscle to bone, ligaments bone to bone. So 2 types of muscle, voluntary, involuntary. 3 types of muscle tissue, cardiac, smooth, cardiac, smooth, skeletal. Cardiac and skeletal are striated. Smooth muscle is non-striated. So one of the things you picked up was a graphic organizer, and that's going to involve the chest muscle build. So eventually we're going to get to a point to where it says build a better body, and you're going to act, once again, I think as a physical therapist, you've got a patient that comes to you and they're, lifting weights, but, they're not bulking up the way they want to. So you're going to talk to them about different muscle groups that are part of their chest muscles. And so that's information is going to go on that graphic organizer. So on the next page, you may, this would be a good place to tape it in, so you may just want to make yourself a note, graphic organizer, build a better body. You can go ahead and tape it in, but it's probably going to be a little bit clumsy to work on the worksheet if it's taped in. And then on the graphic organizer, you may want to make a note at the top, build a better body, and then put it somewhere safe. All right, so I've labeled this next page parts of a muscle because these are going to be all like the little details where we did like the long bone, all the different parts that made up the bone, now all the different parts that make up a muscle. And then I taped in a little muscle picture at the top. All right, so no, not this one. There's stuff below it, but not underneath it. So I'm going to have you go ahead and label this real quick first, and then we'll talk about each one of these in detail. Okay, so a few of them I don't have down here. So obviously bone. So here's our bone right here. That's labeled bone. This is the muscle. The red part is the muscle. The tendon is an extension of the epimysium, but the tendon is that structure that attaches muscle to bone. Within our muscle, it says blood vessel right here, but there are multiple places where blood vessels and nerves are scattered throughout there to bring information, carry information back, and carry nutrients and waste products. So this is one place where it's labeled, but understand you're not going to have one blood vessel in a muscle. It's going to be throughout. Okay, so now I think the rest of these are down here one way or another. All right, so myofibril. Myo, I always associate with muscle. Myofibril. It's a thread, so that's where I get the thread from because it sounds like fiber, myomuscle fiber. Threads that myocytes are composed of. So myofibril, myomuscle fibril fibers, myocyte. We've seen that word site before, that word part. Do you remember where? Say that again? Yeah, so it's indicating cells. Osteocyte. So an osteocyte was a bone cell. Myocyte, muscle cell. So, oops, wrong one. Myofibril, this is basically pulled out. This is a little muscle fiber, and we'll look at that in a little bit more detail. Endomysium. Endomysium, membrane that's wrapped around each muscle fiber. Fascicle. Fascicle is a bundle of those myofibrils. So I have a myofibril, it's wrapped in an endomysium. Then this bracketed area right here has a whole bunch of those myofibrils wrapped in endomysium, and that's a fascicle. Paramecium, another membrane. This membrane wraps around the fascicle. Epimecium. So that was what stretched, well, not stretched, extended. And after it left the muscle fibers, extended off the muscle fibers, it becomes a tendon to attach that muscle to the bone. So epimysium, a tough outer membrane around a group of fascicles. It forms a group of fascicles to form a skeletal muscle. It ends past the muscle fibers, coming together to form a tendon and to attach that muscle to bone. So for me, sort of running this through and memorizing this stuff for me, the first thing is that I memorize myofibril and fascicle. Myofibril, muscle fiber, fascicle, bundle of myofibrils. So memorizing those two terms. The others are just membranes. Endo sounds like inner to me, so that's the one that's wrapped around that myofibril. Epimysium, epidermis, that's the connection that I make, so outer membrane. And so paramysium, that's going to be the one that's in the middle. Say that one more time. S-I-U-M. Oh, paramysium? I don't know. I ain't got no grammar skills. I don't know if that's like related to membrane or epithelial or epithelial tissue. I'm not sure. If you go into anatomy and physiology, I would bet that they go through all that stuff. There you go. Yeah, let me know. I mean, we probably won't, besides here's a fun fact, but I mean, there's a few that we come away with, but not too many. Like sight, you all should know that that's cell by the time we get through with this. Itis, tonsillitis, tendinitis, swelling. Itis is indicating I've got tissue swelling. That's a really good question. Let's get this first. Hold on. Swelling of the tendon. All right, so I've got this little diagram right here. And underneath it, we're going to do sarcolemma, sarcoplasm, sarcoplasmic reticulum, and then I have correspondingly highlighted those terms to where they are on this diagram. But this one I definitely have as a little door. I have personally made a little note for myself that endomysium, because remember endo, that was the one all the way on the inside. It's wrapped around the myofibril. Myofibril is the fiber-like myocyte. So all cells have a cell membrane. The cell membrane of a muscle cell is specifically called the sarcolemma. But then you have that layer, that tissue, the endomysium. So the endomysium would be on top of that cell membrane. So that's just like a little note for me. So I need to organize and put things in place specifically. So on top of the sarcolemma. Endomysium would be the layer on top of the sarcolemma. The sarcolemma, this right here, is like the cell membrane of the myocyte, the cell membrane of the muscle cell. Sarcoplasm, that's just like cytoplasm, but it's a muscle cell, so it gets a special name. Sarcoplasmic reticulum, just like endoplasmic reticulum, it's like a little network of highways, but it's specific to a muscle cell because of the calcium it contains. Okay, so sarcolemma, cell membrane of a muscle fiber. Sarcoplasm, cytoplasm within a muscle cell. And sarcoplasmic reticulum, just like endoplasmic reticulum, network of highways, transport membrane. So endoplasmic reticulum a lot of times is associated with proteins. Sarcoplasmic reticulum is associated with calcium because calcium is a fundamental element in muscle contraction. It's also fundamental in a nerve impulse. It's like a little birdie. Happy little birdie. Ca, calcium. Ca with a little plus is our positive calcium ion. So we saw that when we did our bone feedback loop. So the next 2 pages are the diagrams that have to do with muscle contraction. We are not doing that today. Sliding filament theory, I'll push that notes out or whatever. We can go ahead and the next 2 pages, we can tape these in. This one is taped completely in. This one's got a little door, and this one's taped completely down. We can do that real quick. Yes, you might want to tuck those muscle contraction diagrams in there if you think they'd be safe. And this is just a note to myself. You don't need to worry about that. Just ignore that. Don't worry about that. We'll talk about that when we put them on the mannequins. All right, so as you're taping things in, so like I said, keep in mind for the next couple of days, if we are on distance learning, then I'll push out some stuff so that way we can keep going with the labs that we have. I understand that sometimes, you may not have electricity. I may not have electricity to be able to push things out. But I know that y'all will probably beg, borrow, and steal and fight like rabid animals to be able to charge your phone. So at the very least, you can send me a text in order to tell me what's going on. And if you do have electricity, maybe you don't have internet or something like that, I can send out links so that they're on YouTube and it's watching a video. I mean, you might as well make good use of your time. I understand that you may not be able to do stuff like that, and that's fine too. It's just anybody that is done and ready to go, I'll have them do the muscle builds and stuff like that on the mannequins, and then you can take the time in class to go and watch those videos and add those notes. So ideally, we're all in the same spot, but there might be some things that we have to do in order to take care of that. Monday so far as I know, is still going to be tours. So I would I would love to be able to do the Mind Over Muscle Lab on the students that come here for tours. But that would require us being able to open up that file and you guys be familiar with what you're supposed to do with that file before that day comes. Ideally then, the tours will be a little bit different in that I will have you with a group that you take to each station and you stay with them. That way you take to the station where we do the Mind Over Muscle activity and see how they do on that and just record their data. Then you'd go to the next station with them, and then somebody else would come and record that person's data. That way we have data for that lab. But we'll find out. Who knows? No, I've got it taped down. All the information is on here, so it's expected that you read over that, look over that, have a general idea of those basic bone, muscle, and joint dysfunction issues. All right, we'll specifically give an example of muscle rules here in just a second. But we talked about striations, and so kind of a visual of what's going on. When you do these bone and muscle builds, when you do these muscle builds, not bone and muscle builds, when you do these muscle builds, they're going to talk about drawing lines on the muscles. The lines that you're drawing on the muscles, they're indicating the locations of the origin and insertion, and they're indicating how that muscle contracts, the direction of contraction. Striations are not like that. Hold on. Y'all listen to my melodious voice. You're writing things down. Listen to my melodious voice for just a minute. Hang on just a sec. So this is my muscle right here. I should have made it red, but this is my muscle right here. Here's my tendon attaching it to this bone. Here's my tendon attaching it to this bone. And here would be the joint in between that. So these lines are indicating where the origin and the insertion points are, and they're indicating the direction, if you will, of that contraction. So think just for a moment about when you did the orbicularis muscles. Those were the muscles surrounding the eye or the mouth, and chances are you made, I can't even remember how y'all did that. Something along those lines. Oh, I should have gone over there and looked. Pardon? No, that's not a donut. Hold on, I'll come back to that. That doesn't make sense as it is anyway, because that's going to open it wider. Relaxing. When you do it, it should. But at any rate, those striations that you made on there indicated the fact that that was closing that muscle or was closing that sphincter muscle. So on this one right here, those contractions are closing this up or shortening this muscle right here, shortening that muscle, which is going to cause those bones to move. If I take one of these and lay it out, so that's muscle fibers, but I'm taking one of these muscle fibers and I'm laying it out, these are not striations. These are just what the muscle fiber direction, the muscle fiber, how it's going to contract. If I take one of those muscle fibers and lay it out, the striations, because they're sarcomeres, they are lined up like that. The stripes are like that. There's a difference between muscle fibers and the striations in a muscle. Okay, now you can go draw it. I'm going to go look to see how that was. That doesn't make sense. Oh, okay. That makes more sense. donut. All right, so we're going to talk about muscle rules. All right, rule number 1. Muscles must have at least 2 attachments and they have to cross a joint, especially skeletal muscles. I mean, these are skeletal muscle rules. All right, so one of the first muscles that you put on your mannequin is the biceps muscle. I'm not completely thrilled about where they're putting the origin and insertion on the mannequin, but we'll talk about that when we get that in there. So biceps muscle, do you know where your biceps muscle is? Biceps muscle. Has to cross a joint. What joint do you think your biceps muscles cross? Okay, so it's one of those two, and it only crosses one joint. So which one do you think? Think about what your biceps muscle is doing. When you flex your biceps muscle, what joint is being activated, if you will? So is it shoulder or elbow? Elbow joint. So biceps muscle, the joint that it crosses is your elbow joint. So biceps muscle is attached on the lateral and medial side of the radial groove of the humerus. So that's a lot of big terms, but I bet you know each one of those. Lateral, what does lateral mean? Nope. What does medial mean? Regional term medial. Medial midline. So lateral, out from the midline. Okay, good. Radial. So it's talking about radial side, so radiate where it leads down to the thumb. Of humerus. What's humerus? Okay, so your big upper arm bone. Good, 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 good. All right, and crosses the elbow joint. So it's attached to the ulna just below the antecubital region. What's the antecubital region? Okay, so your elbow pit. And ulna? Ulna is the bone that lines up with your pinky. So radius, rad. Ulna, pinky. P-U, stinky, pinky, ulna, pinky. Whatever it takes. Don't laugh at me. Whatever it takes. All right. Radius, ulna. Okay, so biceps muscle. They have a point of attachment on the humerus. So thumb, imagine the point of attachment on the humerus. And then we have another point of attachment past the antecubital region, past our elbow joint, on the ulna, just below the antecubital region. So thumb on the top, middle finger somewhere close to where your ulna would be past your joint. Go ahead and do it now. This is interactive. Thumb on your humerus, middle finger, or whatever's the longest, past your elbow joint, somewhere around where your ulna would be. Okie doke. All right, so now keep your fingers there. So this is our first rule, has to pass a joint, has to have 2 points of attachment. So now, bend your arm so that your hand comes up towards your body. Leave your fingers there, so do that again. Stretch it out, bend it so that it comes up. Your fingers, keep your fingers on there. Do you see how your fingers are coming together? Rule number 2, muscles always pull and get shorter. So if your fingers are the tendons, points of attachment, and your hand is essentially the muscle, see how it's stretched out? See how when you flex, it contracts, it's pulling and getting shorter. Make sense? Okay, so stretch it back out, 2 points of attachment. So rule number 2 is the muscles are always going to pull and get shorter. Rule number 3, the attachment that moves is known as the insertion, and the attachment that remains stationary is known as the origin. So leaving your hands, leaving your fingers, your tendons, touching to their attachment points. Flex your muscle and see if you can figure out which one of those is actually what's moving. Is your thumb moving or is your fingers moving? Just don't yell it out just yet. Do it a couple times to see. Is your thumb moving or is your fingers moving? Rule number 2, our muscle is contracting. It's shortening up. One of these points is a point of insertion. One is a point of origin, and one is a point of insertion. So we need to determine the insertion and origin. So as you pull it or move it, the insertion remains stationary. The insertion moves. The origin remains stationary. I can't even read my own rules here. All right. So origin. Origin is the one that remains stationary. Thumb or fingers, which one did not move? Okay, so that's our origin. That point didn't move. Your fingers moved up toward it. So rule number 3, fingers insertion, thumb origin. Make sense? Okay, rule number 4. What did I do for that? Okay. Muscles that decrease the angle between the ventral surfaces in the body are known as flexors. Muscles that increase the angle between the ventral surfaces of the body Muscles that decrease the angle between the ventral surfaces of the body are known as flexors. Muscles that increase the angle between the ventral surfaces of the body are known as extensors. We already kind of talked about that when we talked about our range of motion. Flexion, extension, those kind of things. So, bicep muscle, flexor or extensor? Okay? It's decreasing that angle between the ventral surface of the body. That's a flexor. Here's the thing. Rule number 5, let's skip to that in just for a minute. It says muscles must work in opposing pairs. If all you have a biceps muscle is you contract it and that's it. That's all you got. Good luck. But because we have another muscle that then contracts, you're able to extend that arm. Triceps, that's your extensor. So biceps and triceps are working together. They're the muscle pair that allows you that particular movement. Muscle fibers point to the attachments and show the direction of pull. That's what we just did, this part down here. Those striations are perpendicular to the muscle fibers. Okay? Make sense? All right, so I took a little bit longer than I wanted to. Go back to your investigation number 1. Continue working on that. And I'm going to come around and kind of take a look. Let me do this for the folks at home.